look at our notes coming up here. So going to our Google Classroom, looking at the classwork tab in Google Classroom. This is the same in all my Algebra 2 classes. Let's see, week 28, March 6th through 10th. That's us right here. Class notes, and we have two assignments. This assignment 1 is 3.3. It's rationals and exponents. It's more practice with kind of what we're doing because we struggled so much with it. And then we also have a concept check, like a little quiz just to see, are you understanding? So you have two assignments this week. Let's look at the notes. The notes are here. They are available for you to download as you like. And I'm going to put them up on my camera and show you the printed out version of those. All right, so this is our notes for the week. It's just a review over simplifying square roots because we struggle a little bit with that, some of us. And so I want to go over a few things. So if we are simplifying the square root of 75, what we're going to do is pull out all the perfect squares that are underneath there. So we got to look at factoring 75. So 75 is the same as 5 times 5 times 3. Because 5 times 5 is 25. 25 times 3 is 75. So when we bring it down to its smallest factors, the smallest possible factors, it's 5 times 5 times 3. So you'll notice you have 5 times 5. That's the same thing as 5 squared, right? That's the same thing. If you have 5 times 5, that's 5 squared. So we'll rewrite this. Square root of 75 is the same as 5 squared times 3, which is what we had over here. Well, you can rewrite that as 5 squared times square root of 3. I mean, square root of 5 squared times the square root of 3. We know the square root of 5 squared is 5 because the square root and the squared cancel each other out. Or we could say 5 squared is 25. What's the square root of 25? It's 5 either way. So our answer is 5 times the square root of 3, or we write it just like that. We don't have to put a little multiplication in between there. It's 5 square roots of 3. 5 times square root of 3. So that is simplifying a square root. You break it down to its smallest factors and see what squares are in there. There's 2 5s, so that's 5 squared. So that will come out. We take the square root of that. If we have variables, all right, if we have variables, let's simplify 54, square root of 54 x to the 7th. Again, we're removing all the perfect squares. That's our goal. Remove all the perfect squares. So first we have to factor the 54. When we break it down to its smallest possible numbers, and you can do that however you need to, you say 54. Well, that's an even number, so I know I can divide it by 2. Well, that's 2 times 27, right? Because I can take a 2 out of it. Well, 27, 2 I can't break down any farther, but 27, that does not divide by 2, but does it divide by 3? Yes, 3 times 9. So now I've got it broken down to there. 3 can't be broken down any farther, but 9 is 3 times 3. Now it's all prime numbers. That's as small as we can get it. You get it down to its prime numbers. That's as small as it gets. So that's what these are here. 3 times 3 times 3 times 2. So when we look at that, 3 times 3, there's a square. So we can make that a square, 3 squared. There's just one of each of these. So the 3 times 3 moves over to 3 squared. So we just multiply them back together. 3 times 2 is 6. So 3 squared times 6. And then we find the greatest perfect square in x to the 7th. Well, if we take one x out, because if we're looking for perfect squares, we know we can't use the odd number of 7. We have to go down to 6. And when you have a power to a power, x to the 3rd taken to the power squared, that means you're taking x to the 3rd times x to the 3rd because you're taking it times itself, which means when you multiply 2 exponents, you can just add that. So that's x to the 6th. See, so we rewrote x to the 6th as a square because we want to be able to find perfect squares. x to the third squared is a perfect square. And then we have an extra x. So combining everything we got here, we've got this 3 squared plus 6. That's the first part underneath the radical. Then the second part we have, I'm going to do that separate over here. X to the third squared times x, and so that becomes over here. So that's how we rewrite it. We rewrite the 54 as a 3 squared times 6. We write the x to the 7th as an x to the third squared times x. Put them all underneath there. Now we can see what comes out. That is a perfect square. That is a perfect square. We designed it intentionally. We break these apart. See, 3 squared, square root of 6. The square root of x to the third squared and square root of x. We just took all 4 of those terms and made them their own radicals so that we can take the numbers. 3 squared. The square root of 3 squared is 3. Square root of 6, that's as simple as it gets. We can't take anything out of that. The square root of x to the third squared is just x to the third. And the square root of x is as simple as it gets. So since these are outside, we multiply them together and they become the coefficient out here, 3x to the third. This is square root of 6 times the square root of x is the square root of 6x. So we end up taking this up here and simplifying it to that right there by pulling out of the radical any perfect squares. Any possible perfect squares. All right. Let's review square and cube roots then. So to find the square root of number x, we look for the number whose square is x. So this is just like we looked on the front page. 3 squared equals 9, so the square root of 9 is 3. Right? So 3 squared equals 9. We say square root of 9, written as the square root of 9 is 3. Same thing with the cube root. We look for a number whose cube is that x. So since 2 to the third power, 2 times 2 times 2 equals 8, we can say that the cube root of 8, which is written like that, is 2. Since 2 to the third power is 8, then the cube root of 8 is 2. Fourth roots, just continuing that pattern. To find the fourth root of a number, we look for a number which raised to the fourth power equals that number. 3 to the fourth power, which is 3 times 3 times 3 times 3. Because 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. So we say the fourth root of 81, written as the fourth root of 81, is 3. So those are, you can go to fifth roots. We haven't used fifth roots. They work exactly the same way. Our journey continues. The fifth roots work exactly the same way. Since 2 to the fifth power, 2 times 2 times 2 times 2 times 2 equals 32, the fifth root of 32 is 2. So those are opposite. If we raise something to the fifth power or take the fifth root, that's how it works. And it continues on for sixth, seventh, eighth. It doesn't matter what root we went to. 3 to the sixth power is 729. Because if you multiply 3 times 3 times 3 times 3 times 3 times 3, you'll get 729. So the sixth root of 729 is 3. That is our review. We're looking at simplifying square roots. So we're going to practice that this week. Let's look at our assignment. Back to formative.
Yeah, and so when you're answering questions,
See what formative holds for us.
Like what is the
Oh, formative. Okay. Rationals and exponents right here. I'll put up our student preview so it'll look like you expect to see it.
So as a right here, look out.
Formative's fixing some stuff for me because I'm having some problem with it. I was talking to someone at formative this morning, so they're going to fix some things. All right. I want to show you how this works because this is a little different style of problem we've had. Match up the number on the left with the number on the right that it is equal to. All right, we just have 3 problems on this assignment here. Match up the number on the left with the number on the right it's equal to. The only ones you can move are the ones on the left. Like I can grab this and it'll move the 4. See, I can't move the ones on the right. The ones on the right stay where they are. But I want to take 4 and I want to move it to where it's paired up with the one on the right side that it equals. So looking at this, which one of those matches up with 4? Is it 8 to the 2/3 power? Does that simplify to 4? Is it 125 to the 1/3 power? Does that simplify to 4? 125 to the 2/3, 4 to the 3/2, 1/3 to the -3, or 4 to the 5/2. Which one of those matches up with 4? That may take a little work. Well, let's get some suspects. Now, we don't think the 125 is going to work. Those are odd numbers. It's probably not going to equal a 4. So we can probably rule those out unless the other ones don't work at all. We've got 4 to the 3/2. That's one that we can check, but I wouldn't expect 4 to the 3/2 will equal 4 to the 1st. So you think about that. 1/3 to the -3, probably not, and 4 to the 5. So 8 to the 2/3 is probably our best suspect. So let's check and see what 8 to the 2/3 is equal to. So I'll put our notes back up here. 4 to the 3/2 equal 4 to the 1st. No, that's not going to happen because 3/2 is not equal to 1. So that's not going to simplify to 4. What is this though? So let's rewrite it this way. The 3rd root of 8 squared. See, that's just rewriting this as a rational, as a radical. So what is 8 squared? So we want the 3rd root of 64, the cubed root of 64. Well, if we still have our notes from a couple of weeks ago, because these are always useful when we play with this. Perfect cubes. 1, 8, 27. 64 is a perfect cube. That's a perfect cube. And it coincides with 4. 4 times 4 times 4 is 64. So that equals 4. This is the same thing as 4. Those numbers are equivalent to one another. So that means, okay, we've already got it in the right place. Oh, I clicked on that and it made it bigger for me. So yeah, if this was down here, we'd say that's not right. We'll just drag it up there and line up the 4. Like, great. So the next thing, we have to line up 625 to the 1/2 power, whichever one of these it equals. So if we decided that it was 2/3, I don't know if it's 2/3. I haven't looked. I'd move it there. Didn't say the 5. Okay, I like the 5 there. Let's see. 64. I'll put the 64 there. And your lineup to all 6 of them are lined up with what it's supposed to be lined up. I don't think there's a right. I was just moving them. So you got to get all 6 of these correct, lined up with the equivalent expression. Like A is the same as F. So let's put those across from each other. Then you go down here and you have another set of 6 of them. Match them up. The square root of 64 is equal to what? The cubed root of 1,000 squared is equal to what? I'll bet it's not 9 to the 3/2 power. So I might need to drag that down somewhere else. Right. Then your third one, you again have the same thing, but some of these are rationals, some of these are exponents. And you just need to make sure you figure out which one converts to which one. All right. Let's look also while we're going through stuff at our concept check this week. Let's get a preview of that. So here's the other assignment. Like I said, you have 2 assignments. Here's the second one.
You're gonna have the foot and the visceral mass, but then there's also just this empty space.
Hey, there it comes. Oh, look there. I'm watching me work. Simplify the radical expression and give your answer in the simplest radical form. Show all work. This is like the notes that we were just looking at. Show your work. Click on there. You have to simplify that to the simplest radical form. You can use the pencil and you can write. You can type, whatever you want to do. Right. So whatever. you're going to simplify that. Then you have this one, simplify this. You've got 6 cube roots of 2x plus 4 cube roots of 2x. Show your work. Here you have 2 multiplied together. Cube root of 4x to the 5th times the cube root of 2x to the 4th. And simplify the radical expression. 4 square roots of 72x to the 4th minus 2x times the square root of 200x squared. Then we have 2 more problems on the next page. Rewrite this in radical form. Rewrite this in exponential form. And that's it. You have 6 questions on the little quiz, the little concept check quiz. All right. So some of you have it finished 3.2. Some of you have some things you need to go fix on 3.2 because I've looked at a lot of them. I think I've commented on most everybody's if you've had things wrong. So go back and look at that. Make sure that you're using the cube root and 4th root in formative. Don't put a 3 and then a square root. That's not the cube root. Informative counting that wrong. I put a video out there a couple of weeks ago in Google Classroom how to do that. It's like a 4-minute video. If you haven't watched that and don't know how to put cube root in formative or 4th root in formative, go watch that video. Doesn't take long. Teaches you how to enter it correctly. So, all right, guys, that's all I got. I'm out. I ain't got no more. You guys have a great week. If you need some help, hang around, and I'm happy to help you.